Okay guys, in today's video, I want to talk about boundary angles. I encourage you guys to think about what does the word boundary mean, right? So if I drew an XY Cartesian plane, all the angles are not in the first, second, third, fourth quadrant. We call that boundary angles. So such as all the angles on the XY axis, they are boundary angles. So such as 0, 90, 180, 270, 360, etc. So you might be thinking about what's sine 0, what's sine 80, what's cos 360, etc., etc. So in today's video, I'm going to talk about those things from three different perspectives, right? So first of all, I'm going to talk about from complementary angle perspective. So sine 0 is equal to cos 90 degrees and equal to 0. How did I get that? So sine and cos are the complementary of each other. 0 and 90 degrees are the complementary angle, right? And this CO stands for the complementary of sine. Complementary of sine, right? Now you might be wondering, sir, how did I get 0? Aha, that's the thing I'm going to talk about in a little bit more detail in the second and third approach. So second approach, I'm going to talk about from trig graph approach. So let's have a look. Trig graph, right? So if I had a graph like this, that's obviously a sine graph. So 0, 360, and 180 degrees. So sine 0 is 0. And the sine 90, the amplitude is 1. And sine 180, back to 0 again. So let's write these things down of what I've just said. Sine 0 is 0. Sine 90 is 1. Sine 180 is 0. So I'm not memorizing those things. I'm visualize the picture, the diagram, and interpret the diagram. Right? Now cos graph again. That's a cos graph, right? So that's 0. That's 360. One cycle. 180. 90. Now once again, cos 0, you can see cos 0, I started from 1. And cos 90 is 0. So I think about from complementary angle approach, from trig graph approach. Our last one is the unit circle approach. Let's have a look. That one I want to spend the most time to talk about it, which is quite interesting. Alright? So the unit circle approach. So once again, I'm going to draw the Cartesian plane. Right, that's the best I can do. Okay, let's have a look. So imagine the radius of the circle is 1, right? Imagine the radius of circle is 1. So I've got 1, 0 there. Correspondingly, I got -1, 0. Here I got 0, 1. Here I got 0, -1. Now, I'm going to think about the right angle triangle, right? Theta. So this one is obviously y, this one is x. How do I represent x and y in terms of theta? So let's have a look. Imagine the radius is 1, right? So what's sine theta is opposite over hypotenuse. Therefore, y is sine theta. Right? So my vertical axis is represented as sine theta. For exactly the same reason, I've got cos theta is adjacent over hypotenuse. Therefore, x equal to cos theta. Now I'm going to write down x equals to cos theta here. Okay. Now when we represent the point, we always write down the point as x comma y, right? Even from year 7, when we start to introduce Cartesian plane, we know that the point is always represented as x comma y. Now what is x? Based on what we just said, x is cos theta, right? What's y? Y is sine theta. Bingo. Let's have a look, right? So this one is cos theta, this one is sine theta, etc. Okay, in this chapter, we've also said, when we want to represent the angle, we always start from the positive x-axis and go anti-clockwise. Therefore, we've got angle now, theta. We rotate like that, right? Now, let's have a look. So that's 0. I'm starting to rotating 0 to 90 degrees, to 180 degrees, to 270 degrees, and back to 360 degrees. Beautiful. That's the full cycle rotation, one rotation. Now let's have a look. If somebody asks you, hey, what is cos 90 degrees? All right? So you can think, okay, cos 90 is sine 0 is 0. But from the unit circle approach, cos, I'm looking at this number here, 90. So this boundary angle here, obviously I'm picking this number. Cos 90 is 0. Right? I'm just going to explain one more time. 90 degrees, I'm looking at here. Cos is the first number in the bracket. Therefore, cos 90 is 0. Okay, does that make sense? I hope that makes sense. Now, if somebody asks you, hey, what's sine 180? Right? So obviously 180 is here. Sine, I'm looking at the second number in the bracket. That stands for y. So sine 180 is 0. I can always do a quick check, right? That's 360. That's 180. Sine 180 is 0. Okay, let's talk about 270. If somebody say, hey, without using your calculator, can you tell me what's cos 270, right? So cos 270, I'm looking at 270 here first. Cos 270 is 0. So what I'm hoping to demonstrate this is there's no point to memorize every single value. You'll drive yourself crazy if you do that. Remember the picture and everything just flow.